Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can join our community at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, propose show ideas, and follow up with past guests. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. We also have a new sponsor this week. Rollbar is a service for tracking and aggregating your application errors so that you can find and fix the bugs in your application before your users notice that they even exist. Use the link rollbar.com/podcastinit to get 90 days and 300,000 errors for free on their Bootstrap plan. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, and now Google Play Music just launched support for podcasts, so you can check us out there and subscribe to the show. Please give us feedback. You can leave a review on iTunes or Google Play Music to help other people find the show. And don't forget that we have 2 tickets to the Open Data Science Conference in Boston, which is happening on May 21st and 22nd, to give away. In order to enter, just sign up for our newsletter at pythonpodcast.com. Also, if you use the code EP, you will save 20% off of the ticket price. If you decide to attend, then let us know. We'll see you there. Your hosts, as usual, are Tobias, Macey, and Patti, and today we're interviewing Donald Stufft about pip and the Python Packaging Authority. So, Donald, could you please introduce yourself?
So I'm a software engineer for Hewlett-Packard Enterprise, where I work full-time on the Python package ecosystem, which spans from PyPI to pip and other related libraries.
That's really cool that that HP is funding your work with this. It's always really nice to see when companies realize that they're getting enough out of the open source ecosystem, as you said, to actually put their money where their mouth is. So thank you, HP Enterprise. And how did you get introduced to Python?
Yeah, so back in 2007 or so, I was using Drupal to try to make web applications, and it's more of a CMS rather than a web framework. Someone had mentioned to me that there was this new framework on the scene called Django, and Django, as is written in Python. So I went and bought a book and I read through it and taught myself Python so that I could use Django. That's how I got introduced to Python, was through Django.
And how did you get involved with the pip project and the Python Packaging Authority?
Sort of a roundabout way. I care a lot about security, and back then PyPI was not served with a trusted HTTPS certificate. It was using CA cert, which isn't trusted in hardly any browsers. And I sort of got angry about that and yelled a lot on some mailing lists. And I decided I was going to start up my own PyPI called crate.io, which just sort of sucked the data down from PyPI and had HTTPS and a bunch of other things. And then to support features I wanted to put on that, I started sending pull requests and stuff to pip, and eventually they gave me a commit bit, and since then crate.io has been shut down, and I've started working on PyPI directly. But it all sort of started there from me getting angry at the state of security there.
And can you explain a bit about what the Python Packaging Authority is and what it does?
So it's essentially an informal organization of just people working on packaging in Python. It's more or less just to make it easier to say things like the people who work on Python packaging, which is sort of a mouthful. We don't have any sort of like officers or, a whole lot of policy around it. Just sort of if you're working on something that's related to Python packaging and you want to be part of the organization, we add your project and then you're part of the PyPA.
Other than pip, what are some of the other projects that fall under that umbrella?
So there's pip, like you said. There's PyPI itself. There's setup tools is in there. Bandersnatch, which is a mirroring client for PyPI. There's packaging, which is a library called packaging, which is sort of a low-level library that pip and setup tools uses. So there's wheels in there. Warehouse, the new implementation of PyPI is in there, and just sort of a catch-all. I'm missing some, but sort of just a catch-all of things.
How is PyPI and the Python Packaging Authority funded? We're only asking because funding sort of open source infrastructure has been such a hot topic lately, and so many other projects are struggling to figure it out.
PyPA itself, the Python Packaging Authority, that is, we are terrible at names. We have all these names that sort of collide in how you pronounce them. But the PyPA basically has no funding directly whatsoever. We're not set up for it. We've talked about trying to do it before, but as of yet, no one's really stepped forward to actually manage funds coming in. PyPI, on the other hand, is technically the service itself that runs on pypi.python.org is owned by the Python Software Foundation, and it gets whatever money it needs. We have to ask permission and such, but from the PSF board, who then gets funding from donations. But primarily the things that fund it are either volunteers giving their time, companies like mine, which sponsor development, which Hewlett-Packard Enterprise also sponsors a couple other people who work not full-time like I do, but they come over and they work part-time on some of the stuff as it relates to OpenStack more. And then for PyPI itself, a lot of our things are donated by just companies giving us services like Fastly CDN, Rackspace VMs, Heroku's in there. There's a whole slew of services that are donated, well over 20 or 30 grand a month worth of services.
Wow, that's really awesome. Is there a page somewhere that lists who all the sponsors are that we could put in the show notes? I ask only because, like I say, I think sort of recognizing corporate sponsorship of the infrastructure that we all use and depend on is super important so that they recognize the value in continuing that. Yeah,
so there's not currently a real page for doing that. We've sort of half-heartedly tried to do it here or there before. However, the new PyPI, which is live-ish on warehouse.python.org, in the footer has every single company that donates services to PyPI itself, not all of Python, just PyPI. And there's going to be a page there where you can click and get a full page list, with a paragraph describing them and stuff like that, so that those companies are recognized on every page of PyPI.
Super cool.
So I know that there are some languages that don't really have a central packaging and dependency management framework. The first one that comes to mind is Go, where it prefers to go straight out to GitHub repositories. And I'm wondering what your view is on the level of importance for a well-managed and centrally managed dependency framework and packaging architecture for a language.
So I think it's pretty important. I think that it's the sort of thing that people expect nowadays. I worry about what's going to happen in something like Go where they don't have a central repository so much, because what's going to happen in 10 years when GitHub is no longer the cool place to be and some new site, and they're going to have all that code out there that's modified to work directly on, pulling code from GitHub that's, no longer going to be there. Nice thing with PyPI is we've been here for over a decade now, and I'm not going to claim all that code still works, but all the code that has been uploaded is still there available. Might not run on the latest version of Python, but it's still there, and if you just download it, you'll still get that code regardless. But more than that, I think that one of the things that a central repository does is it allows you to abstract your dependencies if you depend on requests. Your requests can come from PyPI, but if you're running a local mirror, it can come from there instead. Dependency information includes concrete locations, makes it much harder to mirror and run sort of dependencies from different locations.
Yeah, and one topic that occasionally comes up when talking about central package archives is the thought of curation, or at least recognizing sort of officially sponsored packages, which I know that in the Python package index, when you're searching for a package, there's sort of a ranking, but I'm curious if you have any thoughts on the idea of curation or sort of reviewing of packages to determine when you're searching for a particular use case, which one you should go with.
Curation is hard to do. It requires a lot of man hours, and it also makes it hard for a beginner to come in and create a new package that then becomes popular. It heavily incentivizes to use packages done by people who you already know. PyPI is not curated, and we probably would never become curated. Now, there is some talk about how we could more able people to develop sort of a curation around PyPI, so that people can maybe make package sets or review packages and whatnot, which I'm not sure if we're going to go there or not. Some of the things I think would probably be better off as an external service that then just pulls the data from PyPI. But I think for a community sort of central repository, you really don't want to get too heavily into curation, because you start then stifling new people coming in and trying to release their packages.
I agree. I think it's very important for something like PyPI to not slow down the development process. I would much rather have, we're so lucky with Python, right? Because there's this amazing wellspring of goodwill that we have, and that on the whole, people who submit to PyPI are doing so for the common good. You might disagree about whether one package is written a particular way or not, but it's not like the iOS or the Android world where we have to necessarily worry too much about malicious Python being submitted to the package system, I wouldn't think. Although perhaps that should be an issue, I'm not sure. But I agree, I think not curating is definitely the default we should stick to.
Yeah, and so you start worrying about malicious packages, you start having to talk about threat models and stuff. And primarily the thing with PyPI as far as security goes is we want to make sure that if you request a particular package, you get the bits that the author uploaded, and those are the ones you meant to get. We are not going to probably ever tell you whether the bits are good bits or not, just whether or not they're the ones the author uploaded and they're the ones you requested.
Absolutely.
And does the Python package index have any support for GPG signing of packages, so that if you have the public key of somebody who you trust to give those packages, that you can actually validate that the downloaded package came from them?
So the answer is yes, PyPI does allow you to upload a signature, but it's not generally useful. Nothing outside of Debian's usescan utility actually validates it, to my knowledge, other than people manually downloading and running GPG. The problem is just signing packages doesn't buy you anything without a trust model behind it. And GPG's trust model was not sufficient because it's focused around verifying identity. So now you can verify that on Donald Stufft, but you have no idea whether Donald Stufft is allowed to sign for pip or request or Django or Twisted. And so you need something to say there, okay, this key is trusted for this particular package. And GPG is just not there yet. We're likely to introduce package signing at some point. It's unlikely to be based on GPG.
Certainly.
So what was involved in getting pip into the standard Python distribution? Was there any controversy around this? I ask because I came from the Ruby community where the act of introducing gem into the standard Ruby distribution almost caused a civil war.
Yeah, so the PEP for introducing that was accepted something like 2.5 years ago, and I'm still dealing with fallout from that. A lot of the Python people, the people who work directly on Python, saw the need for it and were totally okay with it. There was arguments about the specific details about how we were going to do it. In the end, we ended up not including it directly in Python, but instead we included a little installer file that bundled pip. And that was just mostly around so that you could upgrade pip after you install Python. The real fallout, though, came from our redistributors of Python, like Debian Linux, Fedora Linux, FreeBSD, things like that, where they have policies against bundling code, like we bundled pip inside of Python. And there's also then a circular dependency, where Python then depends on pip, but pip depends on Python. And there was a lot of back and forth and arguing about how best to handle that. Like Ubuntu 14.04 shipped with a broken VMs module because they deleted this code that we added for that. But I think we're getting to a better state now where a lot of these things have worked out over time. And a lot of that controversy also came from just like a decade of sort of pent-up hurt feelings about the two sides fighting with each other.
It's kind of interesting because it always seems like there's this tension between language-specific packaging systems and vendor-specific packaging systems. And in a sense, I get it, right? Because for end users, it's always kind of complicated to know, do I use pip or do I install the vendor-supplied RPM-based or Deb-based Python package universe? I think maybe some of that just needs to be handled by better marketing, right? Like, if you're a developer, chances are you're going to want to use pip so you have max flexibility. If you're a system integrator or an infrastructure engineer or someone who is looking to build turnkey systems or systems with configuration management tools like Chef or Ansible or Puppet or whatever the case may be, then you're probably going to want to use the vendor's packaging paradigm because that just makes your job a whole lot easier. So I kind of don't see a problem here, but I recognize why people who are just coming to the table could be very confused by it all.
Yeah, well, and some of the problem, comes from history and just there'd be bad feelings pent up. Some of it's things like, right now, if you go to your Debian Linux and you type pip install something in your user account, it's going to try to install it to the root location, and if you're not root or sudo, it's going to fail. And most people, when they see that permission failure, are going to sudo up and then install into the global site packages directory. So there's some work we need to do around making a better default for people and to try and direct them away from modifying their system with pip instead of using their system packages. And then the flip side of that is we've done that, for so long. We have done that, and it's broken people's systems. And then they go to Debian and say, "Hey, my system's broke. What's up?" And then Debian gets kind of mad. It's not just Debian. I say Debian because I deal with them a lot. But and they get upset with us and want to try to limit people's exposure to things like pip because they see it as a attractive nuisance towards people. So it's a lot of political fallout. We trying to explain. We realize this might lead to more people using pip, but we're also going to try to introduce new concepts here so that people are less likely to mess up their system using pip.
Can you describe some of the mechanics of how pip works and how it differs from some of the other packaging systems that Python has used in the past, such as easy install or setup tools?
Yes, actually, easy install is part of setup tools, but as far as how they fetch and discover packages, they're pretty similar. PyPI has it's actually an HTML page for historical reasons that lists all the files, and they pick which one they like best. They download it and they run a few Python commands and install it. The primary thing that pip had over easy install was that easy install attempted to do a lot of things at runtime. It had sort of a built-in concept of something that's sort of like a virtual environment, but it happened completely at runtime. So, and through sys.path munging. So you wouldn't have a simple, sort of sys.path that Python itself just kind of handled. You'd have this little bit of extra code that would just sort of dynamically alter your sys.path to ensure that the versions of whatever packages you wanted were available at runtime. And this sort of didn't work very well and broke down quite often, and depending a lot on how you started Python stuff. And that really didn't work very well. Pip sort of split that out and started the virtual env project. Said, we're just going to install it into flatly without having any of this runtime stuff into your Python. And if you want to install different versions, you need to use something like virtual env to manage different environments. Then the other thing pip did was with easy install sort of try to install things as quickly as it could. So if it needed to download and install 4 things, would download one thing, install them, go try to download the next thing, install them, and so on. And what would happen oftentimes was you'd get some sort of failure in the middle of installing. You'd leave with a half uninstalled, half installed system, whereas pip tries to offload as much of that work up front as possible and install at the very end after it's already done as much as the other work as it could to reduce the chances of getting into this sort of partially failed mode.
So speaking of virtual env and the like, does pip interact at all with virtual env, pyenv, etc.?
So the answer is yes-ish. Generally, virtual env itself, it installs some patches and does some hacky black magic that is really gross. Then pyenv is a sort of standardized version of that doesn't need all that black magic stuff. But they sort of modify the Python runtime directly without pip's involvement. And then when pip installs a package, it just kind of goes to the Python environment and says, hey, where do these kind of files go? And in that case, if you're not running inside of a virtual environment, you'll get your global site packages. If you are, then virtualenv will have modified that so that it gives you the new location. So in that sense, Pit doesn't need to know about virtual environments because it just asks Python and Python tells it. Now, that being said, there are a few corner cases where we do have to know if we're running under a virtual environment or not. So we do know about them, and we do sort of tweak a few things based on that. But generally, pip is kind of blind to the fact that it's running inside of a virtual environment. It just does the right thing because of the way virtual environments are designed.
That's awesome. It's funny. You're now the third person that I've heard who's really in the know in the sort of, Python internals, Python packaging, etc. world who has talked about some of virtualenv's warts. virtualenv is clearly a really kind of a much needed innovation in the Python programming environment, but everybody seems to cite all the problems with it. Like you mentioned, some of the gross stuff it does behind the scenes. I've heard people say, it's really broken on OS X, et cetera, et cetera. Is there any work or any thought going into sort of packaging in virtual environments the next generation to make it less gross and make everything, be peace, love, and Jerry and working with each other?
I'm also curious if there has been any thought of moving to maybe more of a functional style packaging in the vein of the Nix package management system, where in order to handle multiple different versions of the same packages, you essentially just use hashes of the packages to determine the path that you resolve based on the version that you're trying to retrieve.
So actually, since Python 3.3, there's something very much like virtualenv included in the Python standard library. In Python 3.3, it did not install pip or anything. It was just virtualization, and you then had to go out and get pip and install it yourself. As of Python 3.4, it will install the version of pip that is bundled with Python into your virtual environment by default. And that particular isolation solution eliminates the gross hacks, because a lot of the gross hacks are things like you have to start getting into how the Python interpreter starts up. It looks for a os.py file relative to its binary directory, and if it finds that, then it assumes that's where site packages is. So what virtualenv is, it actually loads that, puts the os.py relative, then puts enough of the site of the standard library in that location that it can bootstrap itself, monkey patch the standard library, then load the standard library from the real location, and then set up your sys.path the rest of the way. The version that's in Python itself just sort of eliminates that, and as part of the runtime startup, it just looks for a pyvenv.cfg file. It says, okay, if this is here, we're just going to assume the site packages is relative to this file, as opposed to what virtualenv has to do, which is sort of shuffle around a half of the standard library using that os.py sigil. So the answer to the question is yes, this all gets a whole lot better in Python 3. Unfortunately, Python 3 is not what everyone's using, so virtualenv is still very popular because it works across all the versions of Python, particularly Python 2. And long term, what I would like to do is refactor virtualenv so that it takes advantage of that built-in isolation where it's available, and then it just uses the old black magic hacks for these older versions of Python that just don't have that. As far as the functional packaging goes, I've looked at that a little bit. I haven't spent a lot of time on it, primarily because one of the things that we currently have working is with virtualenvs and whatnot, is that if you type just the command Python, then it's sort of just working, and what you have installed there is sort of already there. It's available to import and whatnot. And a lot of the functional package managers, it's not the greatest for in-development work, where you're installing things in, and maybe you're modifying it a little bit and tweaking it and then throwing it away. I think we could possibly get there at some point, but it's hard to figure out how to sort of work that in with the 2 decades of legacy understanding of how things work now.
The newest package format for Python is the wheel system. Can you describe what that is and what its benefits are?
Yeah, so the wheel is very similar to an egg, just with some of the sort of misfeatures removed from it. It's, under the covers is just a zip file that, when you're building or installing a package, one of the things you do is you create the sdist, and once you have the source distribution, the sdist, once you have the sdist, you download it, you run setup.py install, or pip does that for you, and it does a number of things like building .c files and then .so files, compiling the .py files and then the .pyc files. All that can take a lot of time. In some cases, like NumPy, I think it can take up to 30 minutes. And what Wheel sort of does is it steps in between the step where you take those .so files and you copy them into the final location. And instead of copying them in the final location, you just stick them in a zip file. And then that zip file gets distributed, and when pip downloads it, all it really has to do is unzip it and copy those files into location. There's a few other little fiddly bits in there, but the sort of 10,000 foot view is it steps in right after you've compiled those files and then just ships those artifacts. So that, it's very similar to .deb packages or such, where they ship compiled bits so that you don't have to do that on the end user machine. It gets a little blurry when you're talking about pure Python packages, but you can think of the step of moving them from your development layout into the install layout as the compile step. The other advantage it has is it has completely static metadata, so there's no need to invoke a setup.py script to find out something like the version number or the name of the package or whatever other metadata that someone might want. It's all in there statically, so it installs a lot faster, even for pure Python, because it's all just static metadata and unzipping and file copies instead of several sub-processes like executing setup.py.
And what are the biggest challenges that you've encountered while working on pip?
Yeah, so not particularly specific to pip, but to all the Python packaging stuff. The biggest challenge is really the weight of the legacy code base there, not just in the code base that you're working on, but we have 500,000 packages, actual individual package files on PyPI spanning over a decade. And people still use some of those, even those old ones, where, we have to be careful how we progress things, because if we just try to throw everything away, say, here's your new system, it's, even if it's the most amazing system in the world, people are going to go, well, I can't install, all my 100 dependencies that I already have. It's no good to me. So you have to be very careful how you progress things so you still maintain compatibility with installing the vast bulk of this. You don't have to keep compatibility for everything, but as long as most of them still install, you're pretty good. But, it's a constant struggle of figuring out how we're going to maintain enough compatibility, then also being careful what we add now, because if someone comes and starts using something we add now, we're going to have to support that for the next decade.
So I'm curious if there are any features that you see in other package managers that you would like to incorporate into pip, or if people have tried to add features into pip that you think don't fit well with it.
So one thing that's not necessarily pip specific, but for packaging specific, one of the things that I think a lot of other package managers or package ecosystems have got going for them that I'd really like to get into Python is the concept of a sort of static binary like Go has, like Rust has, and whatnot, where you can just sort of take all your code, all the runtime stuff, just put it into a single file and ship that off to customers. That is an amazing user experience for when you're trying to give something to a customer who just might want to download this thing and run this little simple binary where they'll have to say, well, first you go install Python, and then you make sure you have pip installed, then you pip install this, and maybe that doesn't work, and they have to figure out, why pip wasn't working on their machine. Oh, you didn't have a compiler, et cetera, et cetera. Some of those systems, or all those systems that I'm aware of that have static binaries, sort of got the benefit of being new. So they didn't have a lot of the legacy stuff that I was talking about. But I think it's something that the other systems, the other languages have that we really should have. We have some things that sort of try to hack it in, like virtual env hacks in isolation. But I think we would need a real first-party supported solution here that will, give people the ability to ship a single file without having too much requirements on what the system already has in place.
What about from maybe like a developer workflow perspective? I know some people, with NPM, the -- save argument, I know people have occasionally asked about that for pip, or the idea of a gem file like Ruby has with bundler. Curious if there's ever been any consideration of adding things like that to the pip library.
Yes, absolutely. -- save is a little, it's a little bit hard to translate some things over, but things like a gem file, I do want to get something like that into pip. We sort of have it with requirements.txt, but requirements.txt requires you to do a bunch of manual things with it. You either don't pin and then, dependencies just sort of automatically get upgraded, which isn't great, or you pin and then you're left stuck managing your entire dependency chain by hand, which is no fun. I really do like the gem file and then gem file lock concept from Bundler, which is just sort of automatically handled, which I'd love to get into pip itself. The npm -- save thing, I wouldn't be opposed to it, but you start getting into tricky questions like, where does it get saved? Is it supposed to get saved to the requirements.txt? Is it setup.py? Well, then you start talking about sort of dynamically modifying a Python file, which starts to get very tricky very quickly. So there's sort of some fiddly bits there to figure it out, which I'm not too sure about that we're going to be able to do very well. But certainly like the gem file and stuff, I certainly would like to get that into Python.
And what does the infrastructure for the Python package index look like, in terms of what is its operating environment, what are some of the server infrastructure and additional services that support it, and also, I guess, what sort of tooling do you use to manage all of that?
So that's a bit complicated because we actually have two sort of environments running at once now. We have warehouse and we have what I call the legacy PyPI, which is the PyPI that everyone interacts with now, which they're sort of running side by side, but they share services too. So sort of to come in as a request comes in, we have Fastly on the outside, which is excellent. Fastly has been a huge help to us. Then Fastly caches almost all of what pip uses, most of the web UI, etc. And we rely on them pretty heavily to scale out to our roughly 8 terabytes a day of bandwidth we use. And then Fastly comes back in and it connects to an origin server, which for legacy PyPI is just it's a Rackspace VM running CentOS Linux on that one, which is just running the PyPI software. For warehouse, it goes to Heroku Dino, running warehouse. Except if they're requesting a package file, which then it hits S3 directly instead of going through our servers. Then we have a PostgreSQL databases in there, which is hosted by Heroku. There's Elasticsearch clusters to handle search for both of them. Then for the statistics, we actually have Fastly streaming logs into our syslog log server, which then buckets that out and throws it into Redis. Then there's an hourly cron job to roll that up, which is how you get the download statistics on PyPI goes through that.
So what have been some of the challenges around scaling some of PyPi's infrastructure to meet demand? I know you talked about Fastly just now, but you also mentioned a PostgreSQL DB in the mix. And I know from my own past experience that caching the static stuff goes a long way, but there's also some fancy dancing required to not massively overload your database servers and the other sort of non-static parts of the system.
So I have to say we're incredibly fortunate with the way that things sort of fell into place. PyPI is vastly read-only. Not read-only, but vastly read-heavy. We do something like 700 new packages a day, and we download several million a day. There's a huge ratio imbalance there. And we sort of lucked into a system where the vast of the smarts of what people are actually doing, which is using pip, is client side, not server side. So almost something like 85% of our traffic or more is requesting fully static pages. That's in terms of request numbers. Something like 90-some% of our bandwidth is requesting fully static things, which are served directly from Fastly. Unfortunately, we have some things with like the XML RPC API, which we can't cache in Fastly. So for there, we have we have some mem cache there to try and cache it locally on the servers. And then we have we just have the one. Actually, we have just the one database server. We're actually not too hard on our database server just because we have the Fastly caching and then we have the memcache caching to try and eliminate where we actually have to hit the database other than writes.
What sort of monitoring do you have in place? Because I'm sure that you need to have something fairly robust, given that if PyPI goes down, then it affects a large number of developers and systems administrators' days.
So we do have PingDom set up to monitor things, but to be honest, our best monitoring is whenever things go down, people start pinging me on IRC and Twitter and yelling at me, telling me it's broken.
That's certainly a good way to make it highly available anyway. So, as you mentioned, you're currently working on a replacement for the PyPI site with the Warehouse project. Can you explain your motivation for that and how it improves on the current system and also some of the technology that you're using for it?
So Legacy PyPI, which we're running today, was written something like 15 years ago. And just to sort of give an idea of what things were like back then, that's prior to Django. I think WSGI came out right around the same time. I think Zope was the primary thing that people were using back then. It was sort of a dark time in web applications, and it came from that time period. And it's never had any significant investment in sort of updating it since then. So you see a lot of really old, really janky code there. And then over time, we've had people kind of come in and sort of try to hack things in, as quickly as they can without sort of looking at the code as a whole. How do we really want to make this code easy to work with? So the sort of side effect of that is, it invents a lot of its own sort of custom one-off things that, were written how they wrote code 15 years ago, and they're just horrible to work with. On top of all that, there are basically zero tests. There's like one or two. And the state of it is it's really hard to run locally. So testing is basically we change something and we push it to production and see if it breaks. So that's obviously horrible. I tried to refactor it and sort of in place to try to make it better, but the code is sort of very spaghetti-like, and any sort of significant refactoring ended up touching the whole thing anyways. So I sort of just kind of gave up and said, okay, I'm just going to start from scratch, rewrite this in a modern web framework, using modern tools, require test coverage, all these sort of good things to have, and say, once we get feature parity, we'll just switch over to this, and then we should be in a better place. So it's written, Warehouse itself is written using like the Pyramid Web Framework. It's Python 30. It uses G-Unicorn as the web server currently. All these sorts of these things, tooling that just didn't exist back when PyPI was originally written. And Richard Jones wrote it back then, and I believe he's commented more than once saying that he had fully expected someone to come along and replace it, within a couple months. This was sort of a proof of concept that never was supposed to be production that we've all been depending on for 15 years.
Yeah, that's any insufficiently ugly hacks will remain permanent.
And PyPI is, living testament to that, the fact that it's ugly and hackish will not stop the world from depending on it.
Yep.
So where do you see the future of dependency management in Python headed?
Yeah, so I see us trying to head more towards more static metadata. It's not completely static metadata. Some things just can't make static, but trying to move static where we can. and trying to get away from a lot of these implementation-defined standards, which has been a problem for us. Like the standard for what an SDIS is the thing that setup tools, actually DistUtils, produces. And this has made it hard to sort of advance things along. So a lot of what we've been trying to do is taking these ideas that people have had over time, say, okay, these are decently good ideas. Let's standardize them, remove the parts we don't like, and focus on standardizing them without saying just whatever this tool produces. And along with that comes with a lot more focus on formats rather than tools, and which will hopefully make it so that setup tools itself is no longer a blessed tool, and it's just another implementation of what a Python build tool could be. But overall, it's a lot of work on standardizing things and trying to make sure that all these pieces can interrupt each other without having to know what these other pieces are.
So a few days ago, there was a big story about how an NPM library was removed from the index, and that broke a large number of other projects and applications. And for anybody who's familiar with the story or isn't familiar with the story, the library that was removed was an 11-line piece of code that left pads a string with white space. And I'm wondering if you think that anything like that could happen in the Python ecosystem, or if there's anything in the sort of general best practices of Python or the ecosystem itself, or even in the package management that would prevent something like that from happening. Did you hear about that story, Chris?
Oh, the left pad fiasco? Absolutely. You'd have to be in a cave or dead to not hear about it. And I feel like it's been... I don't want to be knocking people's work, because Node is awesome and there's been a lot of really great innovation going on in that space. And I really admire it for its kind of youthful exuberance. But I think that has a dark side too, right? They're running into all the same missteps that every kind of, newly hatched ecosystem has. This one in particular was particularly hairy because of the incredibly sort of interdependent nature of Node. I think there's so little... Node has chosen to keep its standard library so light that people really depend on this ecosystem of NPM modules really extensively, and people had no concept that they were going to be breaking the universe like they did when they unpublished that one. So it's been very interesting to watch, and I hope that people are sort of taking note, and that future, when the next big thing comes down the pike, we can all sort of avoid making the same mistake again.
So to answer your question, this could absolutely happen to PyPI. We do allow people to delete things off of PyPI if they wish. We do not allow people to re-upload if they've deleted it, so that's sort of like what NPM was like. However, I think it's less likely that something like what happened to NPM happened, was just simply because of our culture and the way we run PyPI. We are very conservative about how we give up one name to someone else. We pretty much treat it as first come, first serve, unless the person who has it now is willing to give it up, or unless there's specific legal requirement to give it up. So for instance, if someone had the name Google on PyPI, we would require, some sort of legal process from Google to give it to them. Otherwise, unless the person who owned it now says sure, give it to them, they're out of luck. That being said, we are looking into other things that we can do to try and reduce the impact or the damage that someone can do by deleting their projects from PyPI. I saw just recently NPM publish some of the things they're planning on doing, like requiring you to contact support to unpublish something that's more than 24 hours old. Something like that I could see us getting involved in, to do something similar to that. But as it stands right now, we are in a very similar circumstance to what NPM was when this happened.
What's on the roadmap for pip? Are there any planned features that you have in the pipeline that people should be keeping an eye out for? And also maybe list some of the most recent major updates to the pip library itself.
So some of the biggest things, if you haven't upgraded to pip 7.1 at least, I believe it was, you should. You get automatic wheel caching. So like the first time you type pip install LXML, it downloads it, builds it, installs it, caches a wheel, and reuses that, the next time you install it, which saves tremendous time. As far as what's coming down the pipeline, I talked about a few things like finally breaking the hard dependency on setup tools, so it becomes just a another build tool that pip can use, which also would mean you won't have to have that pre-installed, so you only need just pip installed. Trying to change what our default location is for when you type pip install so that we don't incentivize people to install into the global site packages, but instead to a user packages or a virtual environment, maybe something akin to the node modules directory if we can swing it. And then, there's a lot of things that are going to just sort of be internal refactorings, which is going to be a while, but also things like better support for multiple repositories should be coming down the pipeline, and hopefully just sort of general improvements to make things work better.
One question that a coworker of mine had when I mentioned that I was going to be speaking with you is he was curious about what would be involved in building sort of a mirror for PyPI, but one that was just a subset. So if there are just a specific set of packages that they wanted to mirror locally, but then any other packages that weren't on that mirror go out to the canonical PyPI to fetch. So he was saying that he had run into some issues when trying to set up similar to that, so I was curious if you have any input on that.
So there's a program or a package called DevPI, which essentially does that among other things. You don't tell it up front, so you don't give a list of these 15 packages up front, but as you use it, you instruct your pip to use that instead of PyPI, and as you use it, it will sort of a lazy on-demand caching of PyPI where it will go to PyPI the first time, download it, serve it to you, and then save that and cache that locally. Outside of that, there is a tool called Bandersnatch, although that's more for creating a full mirror of PyPI, although it could possibly be modified to take a list and only synchronize that list of packages. I'm not aware of any tool that out of the box takes a pre-formatted list and sort of makes that available to you. Although it shouldn't be terribly hard to modify Bandersnatch to do that.
So, are there any questions that we didn't ask that you think we should have, or anything else that you'd like to talk about before we move on?
No, I think it's pretty good.
One thing I have, I guess, is there any area or particular aspect of PyPI or Warehouse or the PyPA or whatever that our listeners that you would like to solicit help with? Like, where could you use a hand?
So if anyone's familiar with web development, or even if they're not, and they want to help out working on Warehouse, that would be great. The faster we can get that done, the faster we can get rid of the legacy PyPI, and that means the faster we get the nice new shiny PyPI, which has a great new design done by Nicole Harris. So if anyone wants to help out with that, that would be great. We try to set that up so that it's very easy to get started. And, I'm willing to help anyone get set up to work on that.
Maybe we could list the GitHub for that in the show notes.
Yep.
It's, PyPA/Warehouse.
Cool.
So for anybody who wants to keep up to date with what you're doing and the work that you're up to, what would be the best way for them to do that?
Looking at the PyPA GitHub is a good thing, but I think most of the big things get announced on Distritil Sig, and things get discussed there too if they want to get involved, and participate in discussing these sort of higher level ecosystem affecting changes. Then just the various projects which are almost all on GitHub is where the other work tends to happen.
And what about if they wanted to get in touch with you directly?
They can email me. It's donald@stuff.io, or I'm on Twitter as dstuffed, or IRC on Freenode as dstuffed. Any of those work.
Great.
If you find a dstuff somewhere, it's me.
Okay. So with that, I will move us on to the picks. For my pick this week, I'm going to choose a project called Xiki, spelled Xiki, and it's actually a really cool interactive shell that allows you to interact with your shell environment in the same manner as you would with an Emacs buffer. So you can actually, if you type ls, it will then print out an editable list of the files in your local directory, and then you can expand the directory tree, and then once you find the file that you want, you can then take that and put it back into your shell. So it's just a really interesting reimagining of interactivity within a shell environment. So I definitely recommend that people check that out. It's pretty wild the first time you start working with it. And with that, I will pass it to you, Chris.
Excellent. So my first pick this week is a really unusual, well, from my perspective anyway, game, and it's so stupid simple, but it's a really great game. It's a free-to-play. And it really is actually free to play. You can get quite a lot of enjoyment out of it without dumping any money into it. It's called agar.io, and basically you're a cell running around in this cellular world, and you're trying to eat cells and agar that are left lying around, cells that are smaller than you, and you're trying not to get eaten by cells that are larger from you. And it's kind of massively multiplayer. It is one of those things that, okay, you describe it and you say, okay, fine, but you actually play it and it is amazingly compelling. It does require a good net connection, however, but it's a great game. I heard about that on this season 2 of House of Cards, which I'm really, really also very much enjoying. My next pick is going to be Culprate. It appears to be a UK-based electronica band, and they are really fantastic, really great sort of textural, melodic, really, a great deal of complexity. It's just great stuff. You should definitely give it a listen. And my last pick is a book, TCP/IP Illustrated Volume 1, The Protocols. I've been sort of getting back to first principles lately and sort of really studying up on some of my infrastructure lore. And, I've been sort of revolving around the internet and its related protocols for many, many years, decades at this point. And it's been really fascinating, actually. This book is really accessible. And if you're interested in sort of, understanding how IP networking works, how subnetting actually works, how the protocols layer onto each other, and there's just a wealth of really interesting detail in this book, and it's really accessible. It is a great place to geek out and learn all about the nuts and bolts of the internet. And that's it for me. Donald, what picks do you have for us?
So one thing I'm really excited about just was announced today was that you can now run byte-for-byte Linux binaries on Windows 10. And it's really gotten me considering you going back to Windows for the first time in 6 years. So I'm really excited about that. It was announced today at their build conference.
Okay. And do you have any other picks?
Just that one.
Okay, great. I'd like to thank you very much for taking time out of your evening to join us tonight and talk to us about pip and the Python Packaging Authority and the Python Package Index. It's been very interesting, and I appreciate your time.
Yep, thank you.
Thank you, and good night.
See ya.